Good day, folks. Welcome to my YouTube channel. This is a stoichiometry, the basic stoichiometric calculation. Um, Here we're going to calculate the molar mass and the atomic mass. Now, the question it says calculate the molar mass of the following. Guys, calculating the molar mass and then atomic mass here, you use the periodic table. In the periodic table, you use the bigger number, which is the atomic mass, and you use the atomic mass and you don't use the small one. So what we're going to do here, we're given the compound here. So calculating the molar mass of this compound, you say M, and then you put the compound in a bracket, and then the first one is sodium. Sodium in the periodic table is 23. And then how many sodiums? There are two of them there. It's 23 times 2. And then when you go to another one, you say plus. And then sulfur, it's there. You see sulfur, it's there. It's going to be 32. So it's 32. And how many sulfur? It's 1. And then you live like that. When you go to another one, it's oxygen. And oxygen is what? Is 16. Where do you get the 16 there? And then you times by 4 because there are 4 of them, right? And then you have an answer. You have an answer there, and then you punch that in the calculator. So it will be the answer there, it will be gram per mole, whatever that is there. If it was a relative, it was going to be just an answer. Relative, if they said relative molar mass, it was going to just be an answer of that without the grams per mole, right? Now going to the second one, it's the magnesium oxide. The molar mass of the magnesium oxide, you go to the periodic table and get the magnesium. Magnesium is 24, and it's 1 magnesium. And then you go to oxygen, and then oxygen is 16. It's going to be 16 plus 24 is 40. I know the answer of that one out of my head. It's 40 gram per mole, but if it was relative, they said relative molar mass, it was going to be just 40 without the units. Let's go to water. Water is going to be H2O. It's what? It's going to be 1. The hydrogen is 1, and how many hydrogen? It's 2 of them. You times by 2 plus, and oxygen is what? Is 16. So it's going to be 18 what? Gram per mole, right? If it's relative, it's going to be just 18. Now let's look at this one. And this one is, let's say it's a copper sulfate. It's a hydrated one. Copper sulfate, the hydrated one. So this one you need to be careful here. It's going to be M, copper sulfate. It's the hydrated one. So what do you do here? You put copper. Copper is here. It's 40. It's 40, and plus the sulfur, it's 32. And then plus the oxygen, it's 16 times 2. And then when it comes to this water molecule, it's 5 of them. You put plus. This dot here doesn't mean times. It's going to be 5, and then you open the bracket. You open the bracket because it's 5 of water there. So it's going to be 5, 1 for hydrogen, and then times 2, and then plus the oxygen, it's 1 oxygen, and then you put an answer. You just press this whole thing in the calculator, and that's it. Good day, folks. Here's the calculation for the number of moles. The definition for a number of moles is important. A mole is an amount of substance having the same number of particles as are there in atoms of 12 gram of carbon 12. Yeah. Now, calculating the number of moles, we're going to use the formula. It's in the formula sheet that says number of moles is equal to mass over molar mass, right? It's there in the formula sheet. Okay. Now, question 1, it says calculate the number of moles of 1.1. We have 68 gram of calcium sulfate. So using this formula, you are given the mass and you need the molar mass. So in 1.1, the first thing that I'm going to do, I'm going to calculate the molar mass of calcium sulfate. The calcium sulfate is, calcium is 40 plus the sulfate is 32. You get it from the periodic table. and the oxygen, it's 16, and how many oxygen? It's 4 of them. So now calculating, you press that entire thing in the calculator, it will give you 136 gram per mole, right? That's the molar mass. And then you go back to the formula that says number of moles. It's a number of moles of calcium sulfate is equal to mass over molar mass. And then the mass, we're given the mass is 68 gram divided by 136. Your answer there, it's going to be 0.5 mole. So the number of moles, or the amount of substance that are there in calcium sulfate, is 0.5. Let's go to 1.2. At 1.2 it says calculate the number of moles of 47 gram of potassium nitrate. So the first thing as well there, we're going to calculate the molar mass of potassium nitrate, which is going to be, the potassium is 39. Looking at the periodic table, it's going to be 39 plus 14 plus oxygen, it's 3 of them, it's 16 times 3, so it's going to be 101 gram per mole, right? So now we go back to the formula that says number of moles of what? Potassium nitrate. It's going to be mass over molar mass. The mass we're given there is 47, and then it's going to be 47 divided by 101. So it's going to be 0.47 mole. Right, guys, I hope that makes sense, calculating the number of moles. Guys, it can be the other way around. You are given the mass. And they want, you are given the number of moles, they want the mass. So you use the same formula. This one, right? Let's look at now calculating the number of particles. Number of particles, remember guys, the particles, when we talk about particles, we're talking about ions, we're talking about atoms, we're talking about molecules, we're talking about the formula units, right? And remember, the ions you get them from an ionic compound. These two, they come from an ionic compound. Ionic compound, guys, you know what is it? And these two, they come from an element. Okay, the atoms, they come from an element, and then the molecules, they come from a compound, which is the covalent compound, right? Covalent compound. Okay, now let's cut the chase. 1.1, it says calculate the number of particles, right, of 2 mole of oxygen. Remember, oxygen is a diatomic element or a diatomic molecule. So the formula for these guys, it says number of moles is equal to number of particles divided by the Avogadro's constant. And guys, the Avogadro's constant is 6.02 times 10 to the power 23. And we're given in the data sheet at the back. Okay, so what we do here, we have number of moles and we want the atoms specifically. The atoms, guys, okay, I'll show you. Number of moles is equal to number of particles divided by the Avogadro. So we substitute what we have. We substitute 2 mole there, and the number of particles an unknown, and then the Avogadro. This is the Avogadro, right? It's 6.02 times 10 to the power 23, right? So when we punch this in the calculator, guys, it's very important. It's going to be the number of particles. It's going to be 1,20 4 times 10 to the power 24 molecules. Remember, guys, the oxygen is a diatomic molecule. So the first thing that you're going to get there, if you times the number of moles of oxygen, you get the molecules, but the question it wants the atoms. In order to get the atoms, guys, you calculate how many elements are there. How many elements are there in oxygen? There are 2. You're going to times by 2. So when you times that by 2, it gives you now the atoms. You times by the number of elements, it gives you the atom. So the answer there is going to be 2.0, 2.408 times 10 to the power 24. Now it's atoms, right? Now let's go to 1.2. I hope that makes sense. Let's go to 1.2. 1.2, it says 0.5 of sodium chloride. And the sodium chloride, guys, remember it's an ionic compound. And this one, guys, it's a covalent compound, right? So we go to the formula. Number of moles is equal to number of particles divided by that. And then the number of moles is 0.5. 0.5 we times by the Avogadro's constant, right? So when we times by the Avogadro's constant, we times by, we cross multiply there. So the answer there, it will be number of particles, it will be it's going to be 3.01 times 10 to the power 23. Since this is a covalent compound, guys, a covalent compound is going to start to be a formula unit. And then now that we want the ions, the question, it wants the ions, which is the particles, the type of particles, it's ion. Since the sodium chloride, the ions, it's a sodium ion and the chloride ion there. So it's 2 of them. It's a sodium ion and chloride ion. So I'm going to times by the number of ions that are there, number of elements that are there. You can put it that way. You have sodium and chlorine. So it's going to go back to be 6.03 times 10 to the power 23. Now it's what? It's ions. The ions that are there are this much. Now let's go to 1.3. 36 gram of sulfuric acid, and the type of particles there, it's atoms. So we have the mass there. So having the mass there, we're going to change that mass into number of moles, right? So changing that mass into number of moles, we're going to use the formula that says number of moles is equal to mass over molar mass. But as well, for sulfuric acid, we need to have, looking at this formula, we do have the mass, we want the number of moles, we need to get the molar mass. So the molar mass of sulfuric acid, it's hydrogen, which is 2 of them, plus the sulfur is 32 plus 16 of oxygen, and how many? 4 oxygens. So the answer there, it will be 98 gram per mole, right? So we go to that formula, converting the mass into molar mass. Number of moles is equal to mass over, it's very important to put that this number of moles is for what? It's for the sulfuric acid, is equal to mass over molar mass. And then the mass there is 36, we divide by 98. 98 divided by 36 is 0.3673 mole. I did not round off that because I haven't reached the final answer. So now that I have the number of moles, now I'll go to the formula that says number of moles is equal to number of particles divided by the Avogadro's constant. I'm converting the number of moles into particles. Specifically, the particles here, it's what? It's atoms, right? So the number of moles is 0.3673 equal to the number of particles divided by the Avogadro, right? And then when you punch that in the calculator, and you already have the answer in your calculator, when you punch that, you times the answer that you already have in the calculator, which is this. You times by the Avogadro. So the answer, when I punch that, it's number of particles, it's 2.21 times 10 to the power 23. And it's what? Since it's a covalent, this one, guys, it's a covalent molecule. The first thing that you're going to get when you times by the Avogadro, it's going to be what? Molecules. Now, in order to get the atoms, you need to times by the number of elements. How many elements are there in sulfuric acid? It's 2, 3 plus 4, it's 7. I'm going to times by 7 here. It times by 7. And the sulfuric acid, there's 7 elements there. So when I times by 7, the number of atoms it's there are 1.55 times 10 to the power 24 what atoms. Guys, that's the end of this lesson about the number of particles, and I hope it makes sense. Cheers, bye. Hi, grade 10s and 11s. Let's look at the concentration. What is a concentration? This is a simulation where I'll demonstrate for you what is a concentration. Concentration in a definition is a number of solute per liter of solution. Number of solute per liter of concentration is a number of solute per liter of solution. Right, the formula for it, it's C is equal to N over V. It's a number of mole per liter or per volume of solution, right? Now we have this is a solute. This is what you're going to dissolve in water, and the water, we call it's the solvent. It's the one that dissolve water. Right? So what are we going to do in this volume of water? This volume of water, you can see it's a half a liter. And we have the meter here. It's a device that measures the concentration, right? So what I'm going to do, I'm going to pour this solute in the water, which is the solvent, and this solute is the nickel chloride. The nickel chloride, it's going to be like this. It's NiCl2, nickel chloride. It's an ionic substance, it's in a solid state, right? So we're going to measure concentration. So when we mix the two, we are creating a solution, a solution with a concentration. Let's do it. So here, what I'm going to do, I'm going to add this solute here. I'm adding, which is the number of moles. Do you see the concentration has increased from 0? And then if I add more, do you see the concentration increases? From the formula that says C is equal to N over V, what I'm increasing there by adding the nickel chloride, that means I'm adding the number of moles, which means the concentration increases, right? There's a direct proportionality between the concentration and the number of moles. More number of moles, more concentration. What's happening to the volume? The volume is constant. If you look here, it's a half a liter. The concentration remains the same. There are two formulas for concentration. It's C is equal to number of moles divided by volume, which is this is a solute, which is in that case is the nickel chloride, and this is the volume, which is the what is the solvent, which is the water. So, and there's the units for the concentration, it's what, it's mole per dm3. There must be -3 there. If it there's no -3 there, you're going to be wrong, you lose marks. And another one, let's C is equal to mass over molar mass times volume. The units there is going to be the same. It's mole per dm3. This one you use it when you have the mass in grams and the molar mass of the substance that you're dissolving, and this is the mass of the substance you're dissolving. This is the volume of water, which is the volume of the solution. Now let's look at another thing, guys. From this formula, C is equal to N over V. The C is directly proportional to a number of moles when the volume is what is constant, right? Now the question here, it says, what is a concentration of the following solution? The concentration of the following solution, guys, what are we calculating? We're calculating here, it says a 2 mole of solute, which is the sodium sulfate, in 500 cubic centimeter, right? So here, the first thing that you notice here, when you calculate the concentration, you are given the volume. This is V, but this volume, it has to be in dm3, the standard international unit for volume. It's dm3. So we take the 500, we divide it by 1000. It's going to be 0.505 what? dm3, right? And then the number of moles that we have there, and we want the concentration there. So we use the formula that says C is equal to N over V. And then what we do, we substitute. We're going to substitute the number of moles, which is 0.2. We divide it by 0.5, right? 0.2 divided by 0.5, it's going to be what? 0.4. The unit is going to be what? The units is going to be mole per dm3, right? And the next question, it says 2 mole, which is the number of moles of copper sulfate in 4 dm3 of water. So this is the volume. You use the same formula, which is C is equal to N over V. We take the number of moles, which is 2, we divide by the volume, which is 4. The answer will be 0.5 mole per dm3, right? And then 1.3, it says 0.5 of sodium chloride, which is the number of moles there, and the volume, it's 50 dm3. We have to divide by 1000 there, and then the answer will be 50 divided by 1000. It's going to be 0.05 dm3. That's the volume. And we need what? We calculate the concentration. We'll say C is equal to N over V, and the number of moles, it's 0.5. We divide by 0.05, right? So we'll say 0.5 divide by 0.05, and then the answer will be what? 10 what? Mole per dm3, right? Let's look at a case where you are asked to calculate the number of moles of solute, which is, we want the number of moles here in this question in the following. So what we're given the 5 dm3, which is the volume in a standard international unit, and we're given the concentration there, right? So we'll use the formula that says C is equal to N over V, and then the concentration we have is 2, and the volume is 5, and the number of moles is the one that we're looking for. We cross multiply, we'll have the number of moles there. 2 times 5, it's going to be 10 what? Mole, right? Let's leave it like that, guys. I hope you understand the concentration. Cheers.
Here's a question on stoichiometric calculation using the balance reaction or balance equation. It says the reaction between magnesium and dilute hydrochloric acid is represented by the balance equation below. Here's the balance equation. It's a magnesium and hydrochloric acid give you magnesium chloride and hydrogen gas, right? It says during the experiment, 1.5 gram of magnesium react with an excess of dilute hydrochloric acid to produce the hydrogen gas at STP. Now they give us an important information. So they said the acid is an excess. That means the magnesium is a what? Is a limiting. So we have both limiting and excess. But the magnesium 1.5, that is an excess we're given, that is a limiting. That means this 1.5 gram of magnesium is going to react completely. It's going to be used up completely. And then when it reacts with the dilute hydrochloric acid, and then it produces the hydrogen gas at STP. Very important, when they say STP, you must remember the formula that says number of moles is equal to V over Vm. Now let's cut the chase and go to 7.1.1. It says mass in grams. Calculate the mass in grams of hydrogen gas produced. So we wanted the mass of this hydrogen that is produced. Remember, the hydrogen is produced at STP. So what are you going to do? You're going to do what you call a mole ratio. A mole ratio of what you have, which is the magnesium, which is 1.5, and looking for hydrogen. But doing the mole ratio, you need to convert the mass that you are given to number of moles. So we use the formula that says mass Number of moles is equal to mass over molar mass, which is the mass. Our mass is, what is the number of moles? It's the number of mole of what? It's the number of mole of magnesium. Using the formula, it says mass over molar mass. So there it's going to be 1.5 divided by 2.24. The magnesium is 24. The molar mass, you get it from the periodic table, right? So when you punch that in the calculator, you will get the answer that says 0.0625 mole. That's the number of moles of magnesium. So now, in order to get the hydrogen that is asked here, the mass of hydrogen, so you do what we call it a mole ratio. You will say magnesium is to hydrogen, which is an unknown, is to a known is to an unknown. So the ratio there is 1:1. So I put 1:1. And then what are we looking for is magnesium, is hydrogen. And we put the magnesium at 0.0625. And then we cross multiply. Your X is going to be the same as 0.625 mole, which is the 0.625 of what? Of magnesium, right? Of magnesium. Now, what are we going to do now? Not magnesium, sorry, it's hydrogen, of hydrogen. Now we have the moles, we have to change into mass using this formula. Mass over molar mass. So we substitute the number of moles of hydrogen, and then we want the mass of hydrogen. And the molar mass of hydrogen is 1, but since it's a hydrogen gas, it's going to be 2 times of that. And then when you punch that in the calculator, your answer will be, your mass of hydrogen, it will be 0.13 grams. That's a rounded off answer. Now let's go to 7.1.2, the volume and dm3 of the hydrogen gas produced at what? At STP. Now that you have the number of moles, you can just change that number of moles. It's 7.1.2. You can change the number of moles to the mass, right? So, no man, not the number of moles to mass, the number of moles to volume using this formula. Number of moles is equal to V over Vm, right? So we put the number of moles of hydrogen, 0.0625. V is the volume that we wanted, dm3, and then the V is the constant. You get it in the data sheet. And then when you cross multiply your answer there, it will be your V, that's the volume of what? Of hydrogen. It's going to be 1.4, right? It's 1.4 what? dm3, right? So we are done with that question. Let's go to another question. Another question, it says calculate the mass of the magnesium chloride produced. So that's the product. So we want the mass of this that is produced. So what are we going to do? We're going to do the mole ratio of the limiting and this product that we're looking for. And you can see the ratio there is 1:1. So it's going to be the same number of moles. Okay, so 7.1.3 is, we do the mole ratio is magnesium, which is the limiting, is to magnesium chloride, which is the product that is formed. The ratio is 1:1. We're looking for magnesium chloride, and then your number of moles of of magnesium is that, and then we cross multiply, we're going to get the same answer. It's 0.0625 mole of what? Of magnesium chloride produced, right? But the question wanted what? The mass in grams, right? So we're going to change this number of moles. This is the number of moles into mass using this formula. This is quite easy. 0.0625 and then the mass, and then the molar mass of magnesium chloride. Magnesium chloride is what? Is 24 plus 35 times 2, 35.5. The molar mass of chloride, and times by 2. So if you punch that in the calculator, your answer there will be 95 gram per mole. So you take the 95, you substitute it there, and then cross multiply. The mass of magnesium chloride, it's going to be 5.94 grams. That's the mass that is formed today. I hope that makes sense, guys. This question. Cheers. Bye. Good day, folks. Let's look at the molecular formula and the empirical formula. Now it says a compound contains 30.4% of nitrogen. We know when we're given the percentages, we can change that into mass. That means it's 30.4 gram and 69.6% of oxygen. That means it's 69.6 grams. Right? If you add the two, it gives you 100%. Now it says define the term empirical formula. Guys, when it comes to definition, stick to the exam guideline. The empirical formula is the simplest ratio between two atoms to form a compound. Right? Now it says determine the empirical formula for that. So 6.2, the empirical formula. So you put the ratio as you are given there. It's nitrogen and oxygen. So I'll have nitrogen is to oxygen, right? And then what I'm going to do, I'm going to use the formula that says number of moles is equal to mass over molar mass. You need to write that formula. You get the mark for it. So I'm going to take the mass and divide by the molar mass. Mass divided by the molar mass. So it's going to be 30.4 divided by what? 14. And then this side is going to be 69.6 divided by oxygen. Its molar mass is 16. So the answer here, when you punch this in the calculator, you will get 2,1714, and this side it's going to be 4,35. And then these are the number of moles of both. This is the number of moles, this is the number of moles. And then what you do, you take the smallest, which is the smallest is this one. I'm going to divide both by it. So it's 2.1714. You divide by 2.1714. And in this side, 4.35, you divide by 2.1714. And then your answer in this side is going to be 1. And then your answer here is going to be 2 when you round off it. So your empirical formula, it's going to be N and oxygen, and how many oxygen? 2 and 1 nitrogen. You don't have to put the 1 there. Right? It says write down the molecular formula of the compound if the molar mass is 92. Right? So in 6.3, so you calculate the molar mass of the empirical formula, which is this one, which is it's 14 plus 16 times 2, which is going to be, it's going to be 46 gram per mole. So what are you going to do now? You're going to calculate the factor, which is the N. You're going to say the molar mass of the true formula, divide by the molar mass of the empirical formula, which is, it's 92 divided by 46, that is going to be 2, and then that's n, and then the molecular formula now. You get it by taking the n, which is 2, you times by the empirical formula, then which is 2, we times by the empirical formula, it's NO2, we're timesing the ratio there, so it's similarly, we're timesing 1:2. So it's going to be N 2 nitrogen and 4 oxygen. That's the empirical formula and the molecular formula.